So yesterday in the class we had discussed something about D'Alembert's ratio test. Okay, the series sigma un is convergent if limit n tends to infinity un plus 1 divided by un. Okay, is less than 1. Limit n tends to infinity un plus un is less than 1, and limit n tends to infinity un plus 1 divided by un is greater than 1. Okay, this is by D'Alembert's ratio test. The series sigma un is convergent. Now, for homework I had given test for convergence the series 2 by 1 okay. Test for convergence the series 2 by 1 plus 2 into 5 into 8 by 1 into 5 plus 9 and 5 into 9 plus 2 into 5 into 8 into 11 plus by 1 into 5 into 9 into 13 plus etc. till infinity. So let sigma un will be equal to 2 by 1 plus 2 into 5 into 8 by 1 into 5 into 9 plus 2 into 5 into 8 into 11 by 1 into 5 into 9 into 13 plus etc. till infinity. So here we get the nth term un is equal to 2 into 5 into 8 into 11. So first term 2, second term 2 into 5 into 8, third term 2 into 5 into 8 into 11. So nth term will be 2 into 5 into 8 into 11. It goes on till 3n minus 1 because a plus n minus 1 into d. So 2 plus n minus 1 into 3. So it will be 2 plus 3n minus. This is studied from arithmetic progression because there is a common difference. So 2 plus n minus 1 into 3. So 2 plus 3n minus 3, that is 3n minus 1. So 2 into 5 into 8 into 11 till 3n minus 1. The denominator, if you take 1 into 5 into 9 into 13, it goes on. So the nth term in the same way you find out because there is a common difference. 5 into 1, 4, 9 into 5, 4, 13 into 5, 4, like that. So then un plus 1. Un plus 1 means 2 into 5 into 8 into 11 goes on till 3n minus 1. Replace n by n plus 1. So 3n plus 3 minus 1, that is 3n plus 2. Here 1 into 5 n into 13. In this term, replace n by n plus 1. Replace n by n plus 1. Again I am telling. Wherever there is n, put n plus 1. So 4n minus 4 into n plus 1 minus 3. So 4n plus 4 minus 3, that is 4n plus 1. So now un plus 1 divided by un. So what you get? Un plus 1 divided by un. So here you can see un plus 1 divided by un means this is un plus 1. 2 into 5 into 8 into 11 into 3n minus 1 into 3n plus 2. 2 into 5 into 8 into 11 goes on to 3n minus 1 into 3n plus 2 divided by 1 into 5 into 9 into 13 goes on till 4n minus 3 into 4n plus 1 divided by un. So un when you write, it will be reciprocal. So 1 into 5 into 9 into 13 till 4n minus 3 divided by 2 into 5 into 8 into 11 till 3n minus 1. So now here if you see, all of these terms get cancels. 2, 5, 8, 11 till 3n minus 1, 2, 5, 8, 11 till 3n minus 1 cancels. Here 1 into 5 into 9 into 13 till 4n minus 3, 1 into 5 into 9 into 13 till 4n minus 3 get cancelled. So the remaining terms are 3n plus 2 divided by 4n plus 1. So the remaining terms are 3n plus 2 divided by 4n plus 1. Now we apply the limit for this. Limit n tends to infinity, un plus 1 divided by un. So what happens here? When you studied how to apply limit in your first semester and also in QC, this is limit n tends to infinity. So remove n outside. Limit n tends to infinity, so remove n outside. It will be 3 plus 2 by n. 3 plus 2 by n divided by here n outside 4 plus 1 by n. So limit n tends to infinity, n outside 3 plus 2 by n divided by n outside 4 plus 1 by n. So n and n get cancelled. N tends to infinity, 2 by infinity 0, 1 by infinity 0, so 3 by 4. So limit n tends to infinity, un plus 1 divided by un is equal to 3 by 4. 3 by 4. Okay. Now limit n tends to infinity, un plus 1 divided by un. Un plus 1 divided by un equals 3 by 4, that is less than 1. It is less than 1. So by D'Alembert's ratio test, the series sigma un is convergent. By D'Alembert's ratio test, the series sigma un is convergent. Limit n tends to infinity un plus 1 divided by un is 3 by 4, that is less than 1. So by D'Alembert's ratio test, the series sigma un is convergent. Okay, because it's less than 1, convergent. Greater than 1 means divergent. The series sigma un is convergent. Now, test for convergence of the series sigma n is equal to 1 to infinity, 3 into 6 into 9 into 3n divided by 4 into 7 into 10 into 3n plus 1. 5 power n by 3n plus 2. So this problem, if you see, first we write un. This is un. So sigma un, we take the series first. As it is, take the series first. Okay. So sigma un is equal to, sigma n is equal to 1 to infinity. 3 into 6 into 9 goes on till 3n divided by 4 into 7 into 10 goes on till 3n plus 1 into 5 power n divided by 3n plus 2. From here we get un is equal to 3 into 6 into 9 into 3n divided by 4 into 7 into 10 till 3n plus 1, 5 power n by 3n plus 2. This is un, nth term. So un plus 1 is equal to replace n by n plus 1. Replace n by n plus 1. So 3 into n plus 1, that is 3 into 6 into 9 till 3n. Replace n by n plus 1 means 3n plus 3. Here also n plus 1 means replace n by n plus 1. 4 into 7 into 10 till 3n plus 1. 3 into n plus 1 is 3n plus 3 plus 1, that is 3n plus 4. Here replace by n plus 1, 5 power n plus 1 divided by 3 into n plus 1, that is 3n plus 3 plus 2, that is 3n plus 5. Now here you can see un plus 1 divided by un, because D'Alembert's ratio test is un plus 1 divided by un. D'Alembert's ratio test un plus 1 divided by un. So first I will write this un plus 1. So 3 into 6 into 9 into 3n dot 3n into 3n plus 3 into 5 power n plus 1 divided by 4 into 7 into 10 into goes on till 3n plus 1 into 3n plus 4 by 3n plus 5. So divided by un. So un is here, it will be reciprocal because it is divided. When multiplying, it will be reciprocal. So denominator will be numerator, numerator will be denominator. So we get there 4 into 7 into 10 goes on till 3n plus 1 divided by 3 into 6 into 9 till 3n into this also reciprocal 3n plus 2 divided by 5 power n. Now here all the terms get cancelled. Here also all the terms get cancelled here. So remaining terms are 3n plus 3 by 3n plus 4. Here 3n plus 2 by 3n plus 5. So remaining terms are 3n plus 3 by 3n plus 4. Here 3n till 3n plus 1 get cancelled, 3n cancelled. So 3n plus 2 by 3n plus 5 into 5 power n plus 1. So indices, by indices a power m plus n can be written as a power m into a power n. So 5 power n plus 1 can be written as 5 power n into 5. So 5 power n get cancelled, so only 5 will be left. Now we apply the limit that is D'Alembert's ratio test. D'Alembert's ratio test, limit n tends to infinity un plus 1 by un. Limit n tends to infinity un plus 1 divided by un equals 5 constant outside, limit, this is limit lt, limit n tends to infinity. Here you know what we studied in your first semester. So limo n outside, so 3 plus 3 by n, plus here again n outside 3 plus 2 by n, by here n outside 3 plus 4 by n into n outside 3 plus 5 by n. Because limit n tends to infinity, this concept you have studied in module 1, semester 1, limits. Also in your PU level you have studied that. So now here, once you get it, you can write it here as C. This n get cancelled, this n get cancelled. So limit n tends to infinity, 3 by infinity is 0, 2 by infinity is 0, 4 by infinity, wherever n put infinity. 4 by infinity is 0, 5 by infinity is 0. So you're left with 3 into 3 divided by 3 into 3. So 5 into 3 into 3 divided by 3 into 3. So total it will be 5. So we get limit n tends to infinity un plus 1 divided by un is equal to 5. That is greater than 1. Okay, it is 5 and it is greater than 1. Okay, so by D'Alembert's ratio test, the series sigma un is divergent, because if it's less than 1, it is convergent, and if it is greater than 1, it is divergent. If it is greater than 1, it is divergent. Okay. Now, the next problem, test the convergence of the series. This was, see, one type of problem. This is same type of problem. Now what we have is same type. Test the convergence of the series, but the only difference is here the problem there is no x, but in this problem there is x. So you have to be a little bit careful. So question number 7, test the convergence of the series 4 into 7 into 10 goes on till 3n plus 1, okay, goes on till 3n plus 1, divided by 1 into 3 into 1 into 3 into n, that way 1 into 3, 4 into 7 10 till 3n plus 1 divided by 1 into 2 into 3 till n into x power n, where x is greater than 0. Where x is greater than 0. Now what we do, first we take, let sigma un is equal to sigma n is equal to 1 to infinity 4 into 7 into 10 till 3n plus 1 divided by 1 into 2 into 3 till n is into x power n. So here we get un equals 4 into 7 into 10 goes on till 3n plus 1 divided by 1 into 2 into 3 till n is equal to into x power n. This is un. So I hope you understood what you are doing. This is the summation series. The nth term un is this one. 4 into 7 into 10 into 3n plus 1 goes on till 3n plus 1 dot 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 divided by 1 into 2 into 3 till n into x power n. Then we are solving here using D'Alembert's ratio test. So what we do, we write un plus 1. So un plus 1 will be equal to 4 into 7 into 10 goes on till 3n plus 1 into 3n plus 4 divided by 1 into 2 into 3 n into n plus 1. Because after this term you want n plus 1th term, replace n by n plus 1. When you replace n by n plus 1, 3n plus 3 plus 1, that is 4, 3n plus 4. Here also 1, 2, 3 till n terms. The next term will be replace n by n plus 1, that is n into n plus 1 into x power replace n by n plus 1. So much is clear, I hope. Now, according to D'Alembert's test, we have to find un plus 1 divided by un. So un plus 1 I am writing first, that is same thing I have to write. So 4 into 7 into 10 into dot 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 into 3n plus 1 into 3n plus 4 divided by 1 into 2 into 3 into n into n plus 1 into x power n plus 1 by un. So here I am writing the un term. Un term will be reciprocal. So denominator I am writing the numerator 1 into 2 into 3 dot 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 n divided by 4 into 7 into 10 till goes on till 3n plus 1. Then 1 into 2 into 3, 1 into 2 into 3 till n, then 4 into 7 10 till 3n plus 1, then 1 by x power n, because it is the denominator, it will be reciprocal when you multiply. So if you look at this carefully, 1, 2, 3 till n terms, 1, 2, 3 till n terms get cancelled. Here 4, 7, 10 till 3n plus 1 get cancelled. 4, 7, 10 till 3n plus 4. Remaining is 3n plus 4 by n plus 1 into, here there is x n plus 1. X power n plus 1 can be written as x power n into x power 1. So x power n get cancelled. X power n get cancelled. So here what happens, x power n into x, we can write it, that is a power m plus n is a power m into a power n. So x power n plus 1 can be written as x power n into 1. So x power n get cancelled. So you're totally getting 3n plus 4 divided by n plus 1 into x. Now, according to D'Alembert's ratio test, we apply the limit. Limit n tends to infinity un plus 1 by un. Limit n tends to infinity, un plus 1 divided by un equals limit n tends to infinity. Again, to apply the limit n tends to infinity, we bring n outside, 3 plus 4 by n divided by again n outside, 1 plus 1 by n into x. Now, when n and n get cancelled, when you apply the limit, it will be When you apply the limit, it will be n and n get cancelled. This will be 0. 1 by infinity 0, 4 by infinity 0, so only 3, that is 3x. But 3x is not a fixed number, so you have to find out what is the condition for the given series to be convergent, what is the condition for it to be divergent, because unknown x is there in the answer. By D'Alembert's ratio test, the series sigma un is convergent. By D'Alembert's ratio test, the series sigma un is convergent if 3x is less than 1. That is the rule. By D'Alembert's ratio test, the series sigma un is convergent for 3x less than 1, that is x less than 1 by 3, and is divergent for 3x greater than 1, and is divergent for 3x greater than 1, that is x greater than 1 by 3. And the test fails for the value equal to 1, and the test fails when 3x equals 1, that is when x equals 1 by 3. So this is one problem, test of convergence by using D'Alembert's ratio test. So all are very important problems. Don't neglect any of the problems. So next, one more problem we'll see. Question number 8. Test the convergence of the series n cubed plus alpha, sigma n is equal to 1 to infinity n cubed plus alpha divided by 2 power n plus alpha. Sigma n is equal to 1 to infinity n cubed plus alpha divided by 2 power n plus alpha. So we take, let sigma un be equal to the given problem, that is sigma n is equal to 1 to infinity n cube plus alpha divided by 2 power n plus alpha. So we take the given problem as sigma un because it is a given series. So sigma un equals sigma n is equal to 1 to infinity n cube plus alpha divided by 2 power n plus alpha. So in this comparing, un will be n cube plus alpha divided by 2 power n plus alpha. So un will be n cube plus alpha divided by 2 power n plus alpha. N cube plus alpha divided by 2 power n plus alpha. Now un plus 1 means wherever n put 1, let's put n plus 1. Wherever un plus 1 means wherever n put n plus 1. So n plus 1 cube plus alpha divided by 2 power n plus 1 plus alpha. Now according to D'Alembert's ratio test, we have to find un plus 1 divided by un. So un plus 1 will be n plus 1 whole cube plus alpha divided, replacing n by n plus 1, 2 power n plus 1 plus alpha into, that is un, division will be reciprocal. So un is here, so this will be, denominator will come to the numerator because it is division, it will be the reciprocal of the given terms. So denominator un plus 1 is this, divided by un is in the denominator, so the terms is written reciprocal, that is into, numerator will be denominator, denominator will be numerator, so it happens 2 power n plus alpha divided by n cube plus alpha. 2 power n plus alpha divided by n cube plus alpha. Now we try to simplify this. This will be n cubed outside, 1 plus 1 by n cubed whole power 3 plus alpha by n cubed, because I removed n cubed throughout outside. 2 power n outside, so 2 plus alpha by 2 power n. Here 2 power n outside, 1 plus alpha by 2 power n. Here n cubed outside, 1 plus alpha by n cubed. Now we apply the limit. So limit n tends to infinity, un plus 1 divided by un. Limit n tends to infinity, un plus 1 divided by un. For this we apply the limit. So this will be alpha by infinity. When you put n is equal to infinity, it's alpha by infinity. Any number divided by infinity is 0. Then here what happens? So n cubed cancel, 2 power n 2 power n cancels. So here 1 by n cubed, 1 by infinity 0, so 1 cubed 1 plus alpha by n cubed. Again, any number divided by infinity 0. So 2 will be as it is. I have written here 2, here 1, nothing is there, so 1 should be written by 2 plus alpha by infinity, that is 0. Coming to this, 2 power n cancel, n cubed cancel, here 1, because alpha by 2 power n, as n tends to infinity, alpha by infinity, that is, if I take here, if I put here infinity, it will be alpha by infinity, and alpha by infinity is 0. Any number divided by infinity is 0, so it will be 1. Here also alpha by infinity 0, 1. 2 power n, 2 power n, n cubed get cancelled. You should know little bit the basics of the concepts of limits. So finally we are left out with 1 by 2, okay, because here 2 is there. So here it is 1, here also everything 1, so here 2, so 1 by 2. But limit n tends to infinity, un plus 1 by un is 1 by 2, that is less than 1. Therefore, by D'Alembert's ratio test, the series sigma un is convergent. Therefore, by D'Alembert's ratio test, the series sigma un is convergent. By D'Alembert's ratio test, the series sigma un is convergent because the root is less than 1. I hope you are following. Now the next question. Test for convergence. Test the convergence of the series 1 plus 2 power p by 2 factorial plus 3 power p by 3 factorial plus 4 power p by 4 factorial plus etc. to infinity. This is the question. So we take, let sigma un is equal to, we take first, let sigma un is, the given problem is taken as sigma un is equal to 1 plus 2 power p by 2 factorial, 3 power p by 3 factorial, 4 power p by 4 factorial, etc. to infinity. 1 plus 2 power p by 2 factorial plus 3 power p by 3 factorial plus 4 power p by 4 factorial to infinity. We took sigma un. So we write the nth term, and the nth term will be n power p by n factorial. The nth term will be n power p by n factorial, because first term 1, second term 2, third term 3, fourth term 4. So nth term will be n. And the standard form is 2 power p, 3 power p, 4 power, so it's n power p divided by n factorial. U n plus 1 will be replace n by n plus 1, n plus 1 whole power p divided by n plus 1 factorial. U n plus 1 will be n plus 1 whole power p divided by n plus 1 factorial. So now un plus 1 divided by un. So un plus 1 will be, I wrote it as it is, n plus 1 whole power p divided by n plus 1 factorial into un. Un will be reciprocal, n factorial divided by n power p. Okay. Now you should be able to solve problem yourself. I have been explaining, solve the model question paper problems yourself, okay. So what happens here, to simplify this, I will remove n power p n outside, but power p is there, so n power p outside, bracket 1 plus 1 by n whole power p. See this method. Here I am removing n outside, but here p is there, so since p is there, we write n power p into 1 plus 1 by n whole power p divided by, here n plus 1 factorial, 4 factorial can be written as 4 into 3 factorial, like that. N plus 1 factorial can be written as n factorial into n plus 1. That this method you have used again and again. Now this n factorial cancels, n power p cancels. So left with 1 plus 1 by n power p divided by n plus 1. This is un plus 1 divided by un. Now limit n tends to infinity, un plus 1 divided by un, we apply the limit here, limit n tends to infinity, 1 plus 1 by n whole power p divided by n plus 1. Now here 1 by infinity, when you apply n, when you think of n as infinity, when applying the limit, n approaches to infinity. So 1 by infinity is 0, so 1 power p, 1 power anything, 1 power 100, 1000, anything, it's 1 only. So 1 divided by, n is infinity, infinity plus 1 is again infinity. So 1 by infinity is 0, and 0 is less than 1. Not 0, 0 less than 1. But so by D'Alembert's ratio test, the series sigma un is convergent. By D'Alembert's ratio test, the series sigma u, because less than 1 means convergent, sigma un plus 1 divided by un, limit n tends to infinity, un plus 1 by un. If it is less than 1, by D'Alembert's ratio test, the series is convergent. If it is greater than 1, the series is divergent, and if it is equal to 1, it is not defined. So one problem I have given for assignment, discuss the convergence of the series. Very simple, 1 by first term 1 by 3 whole squared, second term 1 into 2 divided by 3 into 5 whole squared, plus 1 into 2 into 3 divided by 3 into 5 into 7 whole squared, plus 1 into 2 into 3 into 4 divided by 4 into 5 into 7 into 9. That is, it's given like this, 1 into, here 1 into 2, here 1 into 2 into 3, 1 into 2 into 3 into 4. See the increasing. So then here 3 into 5, 3 into 5 into 7, 3 into 5 into 79. So what will be the nth term? this power 2 is fixed. You can guess. So I can just give you hint. So sigma un will be 1 into 2 into 3 into 4 dot dot till n terms divided by 3 into 5 into 7 into 9. You have to find out what is the nth term. That is, you can see there is a common difference to 5 minus 3 to 7 minus 5 to 9 minus 7 to like that. So the a is 3 plus n minus 1 into 2. So a is equal to, that is a 3 plus n minus 1 into 2. So 3 minus 2, 1. I think it is 2n plus 1. Mostly the nth term 2n plus 1. Then un plus 1. Replace n by n plus 1. Then replace n by n plus 1. Replace n by n plus 1. Then once you get un and un plus 1, do the division, that is un plus 1 by un plus 1 write as it is, un write reciprocal, and see how many terms get cancelled. Everything is over, apply the limit. When applying the limit, try to bring 1 by n. That is, if n is there, remove it outside, you will get 1 by n, because limit n tends to infinity, 1 by infinity. 1 by n is 1 by infinity, or 1 by n squared, 1 by n cubed, etc. 1 by infinity, that is equal to 0. So this is the method. So since there is another 2-3 minutes, I will just recall once again what you did today. Yesterday in the last session, I had given you for homework one problem. So that problem I solved first. See, same way they have to you have to solve the problem what I gave today. So the nth term will be 2 into 5 into 8 into 11 till 3n minus 1. How I got it? By using this formula, because it is in arithmetic progression. 5 minus 3, 2. So formula for nth term is a plus n minus 1 into d. Same way find out this, you will get this. And then once you get un, this is the series. This is the nth term. Now you got n plus 1th term. Replace n by n plus 1. 3n plus 3 minus 1, 3n plus 2. Writing as it is 4n plus 4 minus 3, 4n plus 1. Now the common ratio un plus 1 divided by un. Common ratio un plus 1 divided by un. So you get it as, you can see here, un plus 1 first written as it is. Then when you write un, it is written, denominator is written first, numerator down. Denominator, numerator, denominator written up, denominator written down. That will be reciprocal. So everything cancels. So left with 3n plus 2 by 4n plus 1. Then apply the limit. You know how to apply the limit. Studied lot of problems in first semester and also in PUC. So you will get, you remember when you apply the limit, n outside, 2 by infinity 0, 1 by infinity 0, so 3 by 4. So we got un plus 1 divided by un is 3 by 4 less than 1. So by D'Alembert's ratio test, the series sigma un is convergent. Same way this problem, first I took sigma un, then I wrote the nth term, then replace n by n plus 1, then un plus 1 by un you wrote, then simplified it, you got it as 5. So you got by D'Alembert's test, ratio test, limit n tends to infinity, un plus 1 divided by un is equal to 5, and that value is greater than 1. So if limit n tends to infinity, un plus 1 divided by un is greater than 1, sigma un is divergent. See this problem again, this is the series I have written, then this is the nth term, then n plus 1th term, replace n by n plus 1, un this n will be replaced by n plus 1, then un plus 1, write the un plus 1 term, divide by un, write the reciprocal, everything cancels, you will get like this. Apply the limit, here n outside, 3 plus 4 by n, here n outside, 1 plus 1 by n, n and n get cancels, so this will be 3x. Now here it's not a fixed number, so by D'Alembert's ratio test, the series sigma un is convergent if 3x less than 1, that is x less than 1 by 3, and divergent if 3x greater than 1, that is x greater than 1 by 3, and the ratio test fails if it is equal to 1. Same problem here, test the convergence of the series. N cube plus alpha by 2 power n plus alpha, sigma n is equal to 1 to infinity, take it as sigma un, that is the nth term, n plus 1th term, replace n by n plus 1, un plus 1 divided by un, here again I have written n cubed outside, so we get like this, here I have written 2 power n into 1, that is 2 power n I have written outside, so 2 power n, 2 power n plus 1 will be 2 power n into 2, so 2 power n outside we get like this, here 2 power n outside, here n cubed outside, cancelling term cancels, denominator n means limit n tends to infinity will be 0, so 1 by 2, that's 1 by 2 less than 1. So by D'Alembert's ratio test, the series sigma un is convergent. We take this, the nth term is n power p by n factorial, n plus 1 term will be n plus 1 power p by n plus 1 factorial, un plus 1 divided by n, this is the n plus 1 term, this is the nth term, the nth term is written reciprocal, you know that, then here see, Here I written n power p. I took n power p outside. So 1 plus 1 by n power p. All this concept you studied in limits. And then here n factorial cancels, n power p cancels, left so much. So limit n tends to infinity, un plus 1 divided by un equals, limit n tends to infinity, 1 plus 1 by n power p divided by n plus 1. So n tends to infinity, this will be 1 by infinity 0. So here also infinity plus 1 is infinity, 1 by infinity 0. Okay, 0, you see it's a number less than 1. So by D'Alembert's ratio test, the series sigma un is convergent. This problem I have given for homework, just solve it. It is similar to the problem number 1, first problem I solved today. Okay, do it and not finding any positive response. Okay, copy the notes. Once again, I'm telling you, I'm very strict about it. I'm going to check the notes when you come. Copy the notes, do the assignment 1. Okay, do it in A4 sheet paper, I will check it. Is it clear? So I think today we solved problems in D'Alembert's ratio test. You should be thorough in that by now. We solved many problems. Some more problems, important problems we'll solve. Tomorrow's session at 11. I'll wind up the session here. Thank you. All the best.